Hello everyone, my name is Azaria Simanjuntak. My student ID is 103012340356. I'm from the undergraduate program of Informatics, Telkom University, and today I will present my final project proposal entitled Comparison of VG16 and ResNet 50 for facial expression classification of the anime character Karo Kawaguri using transfer learning. In this proposal, I focus on facial expression classification in anime character domain. Specifically, I use the character Karo Kawaguri from the anime The Fragrant Flower Blooms with Dignity as the research object, and I compare to CNN-based transfer learning architecture, which is the VG16, also the ResNet 50. Okay, so background, the anime facial expression are different visual domain. The background of this research starts from facial emotion recognition or FER. In general, FER is a computer vision task where a model receives a facial image and predicts the emotional expression shown by the face. Most FER studies use real humans for their datasets. These datasets are very useful, but they mostly represent realistic human facial structures. The problem is that anime faces are visually different from the real human faces. Anime characters are often have larger eyes, simplified nose, unrealistic facial proportions, and exaggerated expression. Because of this, a model that performs well on real human faces cannot automatically be assumed to perform well on anime faces. In this research, I use Karu Kawaguri as the object because she appears repeatedly across the anime and shows many facial expression. By focusing on only one character, the task becomes more controlled because the model does not need to learn difference between multiple identities or drawing styles. The expression classes are limited to happy, sad, and neutral because these classes are really common and easy to understand and suitable for manual labeling from anime frames. So the main research focus is to build a character-specific dataset and compare Tusian and transfer learning architecture fairly. Problem formulation, scope, and objectives. The main problem for this research is how can Karo Kawaguri expression be classified into happy, sad, neutral using transfer learning. These are several challenges behind this problem. There are several challenges behind this problem. First, the dataset does not already exist, so it must be constructed from anime video frames. Second, not every frame is usable because some of frames may contain blur, occlusions, side pose, repeated scenes, or non-targeted character. Third, set and neutral expressions may look similar, so both manual labeling and model prediction may become difficult. The scope is limited to one character, which is the Karo Kawaguri. The input is visual facial image only. This research does not use audio, dialogue, body gesture, or scene context. The objectives are also shown on the slide. First is to construct a facial expression dataset from the anime episode frames. Second, to implement VGG16 and ResNet 50 using transfer learning. And third, to evaluate both models using same dataset, preprocessing, training, configuration, and metrics. And lastly, fourth is to analyze error patterns, especially confusion between set and natural expression. And then next we move to research gap, novelty, and hypothesis. So the research gap is the most facial expression recognition studies focus on the real human faces, although some studies related to cartoon or anime images, they usually do not focus on one specific anime character, and they do not specifically compare VGG16 and also ResNet 50 for a three-class expression classification task. The novelty of this research has several points. First, is the research construct a character-specific facial expression dataset of Karo Kawaguri from the anime video frames. And second, the dataset construction uses a semi-automatic pipeline. This includes frame extraction, anime face detection, character matching, cropping, resizing, quality filtering, duplicate removal, and also manual expression labeling. Third, this research compares VGG16 and also ResNet 50 under the same experimental condition. This is important so that the comparison it will become fair for both of them. And fourth, the evaluations does not only look at the overall accuracy, but also class level performance and error patterns. The hypothesis is that the CNN-based transfer learning can classify anime faces expression into happy, sad, and neutral. The second hypothesis is that ResNet 50 is expected to achieve a higher macro F1 score than the VG16. because the residual connection may help preserve the useful of low-level features while also learning the deeper representation. So this is our literature position. This slide summarizes the position of this research compared with previous study. The first research stream is a human facial expression recognition. These studies support the use of CNN and transfer learning for expression classification, but the domain is different because they use real human faces. The second stream is a cartoon or anime-related studies. These studies show that styles expression can be analyzed computationally, but they also not focus on one specific character. Do not compare VGG16 and ResNet50 in the same setting. The third stream is a VGG and ResNet based face research. These studies support the use of VGG and ResNet architecture for facial recognition extraction, but many of them focus on face recognition or identity recognition rather than the expression classification itself. Therefore, my research is positioned between these areas. It moves the FER from general human face dataset into a controlled anime character, which is the Karokowaguri, with a specific focus on the three expression classes. And also my methodology, the methodology is divided into two main flows. The first flow is the dataset construction. The input is anime character videos, and the output is labeled face image of Karo Kawaguri. These flows include the frame extraction, face detection, character matching, cropping, resizing, filtering, and duplicate removal, and also labeling. The second flow is model training and evaluation. The labeled images are used to train the evaluate the VG16 and ResNet50. Both models are trained using the transfer learning, and the evaluation results are compared. The final output of the system is not only the prediction expression labels, but also a controlled comparison between VG16 and also ResNet50. This comparison will use macro F1 score, class level performance, confusion matrix analysis, qualitative inspection of the misclassified sample, and so the dataset construction and model comparison are connected, which will make a reliable dataset is needed before the model's result can be trusted. And then we move on to dataset construction pipeline. So the input data are 30 episodes videos from the anime Fragrant Flower Blooms with Dignity. From these videos, the frame will be extracted using a configurable interval. After that, the anime face detection is performed using the YOLO-V3 based anime face detector. This is used because anime face have different visual structure from real human, right? And then so a detector designed for anime style face is more suitable. Next, the character matching is performed. This step checks whether the detected face belong to Karo Kawaguri or not. The matching uses image embeddings cosine similarity. If the face confidentially matches the character Karoko, it will start as a candidate. If it does not match, it will be ignored. Borderline case, if the borderline case can be referred manually. Then the face is cropped and resized into 244 by 244 RGB format because that is the standard input size for VGG16 and also ResNet50. And after that, the quality filtering and duplicate removal are performed. This step remove the blurred face, occult face, incomplete face, non-target character, and near duplicate frames. And finally, the remaining images are manually labeled into happy, sad, and neutral. Okay, and then the data requirement and splitting fans, as you can see here, the data source is 30 anime videos. The target data is approximately 3000 face images with around 1000 for each classes, which is the happy, sad, and neutral. And also the size is going to be 224 times 224 times 3, which is the RGB model input. And also I've used 20 to 30 reference images. And model design is controlled VG16 versus ResNet50 transfer learning. In the classification stage, I compare to architecture, which is the VG16 and also ResNet50. VG16 is used as the sequential CNN baseline. It has a straightforward structure with stacked convolutional blocks, which makes it suitable as a comparison model. ResNet50 is used as the residual CNN comparison models. The main advantages of the ResNet50 is its shortcut connections, right? Which will allow us information to pass more directly through deeper layers. This may help the model learn more complex feature while preserving low-level visual details. To make comparison fair, both models will use the same classifier head. The original classification layer is removed and replaced with a global average pooling, a dense layer with 256 neurons and ReLU activation, dropout with a rate of 0.5, and a final dense layer with 3 neurons and softmax activation. The training strategy consists of two stages. In the first stages, the pre-trained base is froze and only the new classifier head is trained. In the second stage, the selected deeper layers are unfrozen for partial fine-tuning. Both models will use the same ImageNet pre-trained weights, Adapt Optimizer, categorically and cross entropy, early stopping, and learning rate reduction. And then experimental scenarios and evaluation metrics. The evaluation plan consists of 5 experimental scenarios. The first scenario is dataset construction validation. This checks whether the dataset contains the valid Kawagory image or no, acceptable image quality, clear labels, and also reduce duplicates. The second scenario is VGG16 transfer learning. This tests how well the VG16 performs on the 3 expression classes. The third scenario is the ResNet50 transfer learning, which is also tests whether the residual architecture gives better performance than the VG16. The fourth scenario is the model performance comparison, which is we are going to compare the results of VG16 and also ResNet50, and it's going to be compared under the same condition. The fifth scenario is the class level and error analysis. This is important because some expressions, especially the set and natural, may be visually similar. The primary evaluation metric is macro F1 score because it treats all the classes equally. Supporting metrics include accuracy, precision, recall F1 score, and weighted F1 score, confusion matrix, misclassified sample inspection, and also the selected grad camp visualization. The final comparison will report mean and standard deviation across the random seed. And also this is going to be the activity schedule and expected contribution. This research is planned for 6 months. The first month is going to focus on literature study and research planning. The next stage included the video, reference, and image collection. After that, the dataset construction process will be carried out, including the frame extraction, face detection, character matching, quality selection, duplicate removal, and also manual labeling. The next stage is model design and implementation, followed by training, testing, and evaluation. After results are obtained, I will analyze the model comparison, inspect class level errors, and write the final report. The expected contribution of this research is threefold. First, this research provides a dataset construction workflow for Kawagory facial expression classification. Second, it provides a fair empirical comparison between the VGG16 also of ResNet50 in a styles anime domain because the dataset that we are using is anime character. Third, it provides analysis of class level errors, especially for visually similar expressions such as set and natural. Thank you for your attention. I hope this proposal can contribute to facial expression recognition research in styles visual domains, especially the anime character facial expression classification.